Welcome. So now we're going to be finding the x-intercepts for graphs of quadratic equations. All right, so we have our equation here in standard form. All right, everything is on one side. F of x equals 2x squared plus 8x plus 6. And we're going to be using factor by grouping. Sometimes you'll be able to use factor by grouping. And sometimes if your equation is not factorable, you'll have to use another technique. Right? Maybe it's solving by using square roots. Maybe it's quadratic formula. Maybe it's completing the square. The two that work with all are completing the square and quadratic formula. But we don't want to use those if we don't need to. All right, so first thing I notice, the first thing we should do is when we're solving, we need to substitute 0 for f of x. Or if there's a y there, substitute 0 for y. Now that I've done that, I notice that we have a greatest common factor. So you should divide all terms by your greatest common factor if there is one. Right? If we were just factoring and rewriting, we would need to keep that greatest common factor as one of our terms in front. Since we're solving, we don't need to keep it. We can simply divide everything by our greatest common factor. So our greatest common factor is 2. So let's divide everything by 2. All right, so now I have 0 equals 2x squared divided by 2 is x squared, 8x divided by 2 is 4x, and 6 divided by 2 is 3. Now, what if you weren't sure that this was factorable? Well, you could always use the discriminant. And I'm going to use the discriminant with the reduced equation as well as before we reduce that other equation. All right, so I'll start with the non-reduced. All right, so let's say I didn't reduce right off the bat. I wanted to make sure I could use the discriminant. Right? I wanted to make sure I could factor, so I used the discriminant. All right, so our A is 2, B is 8, and C is 6. All right, and so my discriminant is what would be under the radical for quadratic formula is b squared minus 4ac, and it tells you if your equation is factorable and what kinds of solutions you have. Do you have real rational solutions? Do you have real irrational solutions? Or do you have complex solutions? All right, so we have our discriminant is going to be equal to, all right, so we have 8 squared minus 4 times 2 times 6, right, and that would be 64 minus, so it would be 4 times 2 is 8, 8 times 6 is 48, right, and that's going to be equal to 16. Well, that's a perfect square. Maybe I should put PS. You look at this later, you'll never remember what PS was. I'll write it out. I just don't have a lot of space. I'm just going to squeeze it in. Let me fix my M there. So this is a perfect, oops, I don't have my eraser in the right spot. This is a perfect square. Right? And it's a positive perfect square, which means we have 2 real, and I'll put rat for rational solutions. They're 2 real and rational. All right, so that means that we can factor. What if we use the reduced one instead? Does that still show we could factor? All right, well, in this case, A is 1. B is 4, and C is 3. Right? And so now let's plug that one in to the discriminant formula. And I'm going to move that down just a wee bit. And I'll squeeze this over here. All right, so we have b squared minus 4ac, and that would give us 4 squared minus 4 times 1 times 3. So that's 16 minus 12, and that's equal to 4. Also a perfect square, right? So you can reduce first. And matter of fact, you can reduce and then still be able to, I guess I have to leave these together, and still be able to use quadratic formula or completing the square with the reduced form, with the reduced equation. I'm just going to fill in this word here. 2 real rational solutions. All right, so that means we can factor. All right, so for factoring, we have to multiply a times c, and we're looking at what 2 numbers that multiply to give a times c, and add to give you b. All right, so I'm going to put that, I'll just put this over here to the side a little bit. All right, so I have multiplies to give me, so a is 1, because I'm going to use the reduced one. Why would I use the unreduced one, right? So a is 1 and c is 3. 1 times 3 is 3. So we need two numbers that multiply to give us 3, but add to give us 4. Well, that would be 3 times 1 is equal to 3, and 3 plus 1 is equal to 4. All right, so that means we're going to replace the 4x with a 3x and an x. Or, if you want, an x and a 3x. You can switch the ordering. So 0 equals x squared. I think I'll put the x first. As x squared plus x. Right, and those two become a group, plus 3x plus 3. And I could switch the x and the 3x, and I would still get the exact same two factors. Right? So the ordering doesn't matter in the middle there. I just thought I would put the 3x with the 3 and the x with the x squared. All right, so now we'll factor out our greatest common factor. So from x squared and x, we can factor out an x. We'd be left with x plus 1, right? Because x squared divided by x is x, and x divided by x is 1. Greatest common factor for 3x and 3 is positive 3. 3x divided by 3 is x. 3 divided by 3 is 1. And now we can factor out that repeating factor, right? So both of them have the same factor, so we can factor it out. Just like you did with the x squared plus x, they both had a factor of x. And the 3x plus 3, they both have a factor of 3. Well, now our x times x plus 1 and 3 times x plus 1 both have a factor of x plus 1. So let's factor that out. X plus 1, and then if we divide x times x plus 1 by x plus 1, we're left with x. If we divide 3 times x plus 1 by x plus 1, we're left with 3. We've simply factored out that x plus 1. And now we have our factors. All we have to do is set those equal to 0 to find our solution. So x plus 1 is equal to 0. You subtract 1 from both sides. X is equal to negative 1. X plus 3 is equal to 0. Subtract 3 from both sides. X is equal to negative 3. All right, so that means we have two x-intercepts. And they are at negative 1, 0, and negative 3, 0. And that's all there was to it, right? Sometimes when we are solving these, we'll always have solutions. We don't necessarily always have x-intercepts. Right? If you get a complex number as your solution, that's not going to be an x-intercept, right? Because our parabolas are going to be graphed on the real number coordinate plane, not the complex coordinate plane. All right, so that's all for this one. And really, this is just a review of what we started with when we were solving quadratic equations, right? Factor by grouping. Let's continue. And now we have this one. So now we're solving for an x-intercept, and it's in vertex form. We're still going, and we're going to do the same steps all the time. We're solving from vertex form. The last thing you want to do is change it from vertex form. That would be a mistake. Even if it was factorable, it turned out it was factorable, it would still be a mistake because you're giving yourself more work than you really need to. Right? You can solve it just the way it is simply by isolating your something squared. So the very first thing we need to do is, so our goal, by the way, you can see it up there, we have vertex form. Your goal is to solve using square roots, so we need to isolate the something squared. All right, so we're going to substitute 0 for y or f of x, just like we did before. All right, so because we're looking to see when y is 0, and f of x is the same thing as y. All right, so we have 0 equals 2 times x plus 2 squared minus 2. Right? And now it's just the opposite of the order of operations. Right? We want to isolate the something squared, so the first thing we need to do is get that minus 2 away from it. So how do we do that? We add 2 to both sides. So now we have 2 equals 2 times x plus 2 squared. All right? We still don't have our x plus 2 squared isolated, right? Because this is our something squared. Right? We want to solve for this. It's a something squared. You don't care what the something is right now. You just need to get that alone. Right? So how do we get that alone? We're going to divide both sides. Since we've got a factor of 2 there, we're going to divide both sides by 2. And that will get rid of that 2 in front of our something squared. Right, so 2 divided by 2 is 1. And now we have just x plus 2 squared. All right, so I'm just going to kind of refer to the steps now on the right. So we did addition, always going to do addition subtraction first, then division, unless the a value there is 1. Then you're going to take a square root, and don't forget the plus or minus on the constant, right? Because there are two numbers, if I square them, that I'm going to get a 1. All right, so we got plus or minus square root of 1 equals the square root of x plus 2 squared. So 1, that's a perfect square. So we have plus or minus 1, the square root of 1 is 1, equals square and square root cancel, so now you have an x plus 2. You have no radicals, you have no complex numbers, there's no I, so you need to get everything, we're going to first of all, we have to isolate the x, and then we're going to simplify because we can combine our terms because there's no radicals and there's no I. So we're going to subtract 2 from both sides, that goes in front. So we have negative 2 plus or minus 1, always that goes in front, right? No matter what. In this case, we're going to be able to split that and get our two solutions. All right, so now you have two solutions. If you leave it like this, it is incorrect because you need to simplify. So x is equal to negative 2 plus 1, and x is equal to negative 2 minus 1. All right, we can combine those. So negative 2 plus 1, that's negative 1. Negative 2 minus 1, that's negative 3. And so our x-intercepts are negative 1, 0, and negative 3, 0. And that's all there was, all right? So you're just going to isolate your something squared, take a square root of both sides, right? Then you're going to isolate your x. If you can combine terms, you need to do that, right? And you can combine real numbers that don't have radicals on them, right? So real rational numbers, they can be combined. All right, let's look at, I think I have another example of this over here. All right, so this one I don't think is in, this one is not in your notes, I don't believe, but I wanted to give us one more example just to review through the steps. All right, so first thing we need to do, we need to substitute 0 for f of x. So we have 0 equals 5 times x plus 4 squared minus 2. All right, now we're going to add 2 to both sides because we got to isolate this something squared. So addition subtraction first. So we have 2 equals 5 times x plus 4 squared. And you know, it says division there, but actually go back over here and in your notes put division multiplication in your, I'm going to put that in red. So in the future, if I don't remember to change the notes, put division multiplication. We're dividing if that coefficient in front of the something squared is an integer. We're going to multiply by the reciprocal, right, if it is a fraction. So division, and that value happens to be a, right? So if a is an integer, and multiplication, I hope you can read that, multiplication, and then it would be by the reciprocal if a is a fraction. Because if that had been a 1/2 instead of a 2, right, we wouldn't have divided by 1/2, we would have multiplied by 2. Right, so we'll just put both of those in there. And I'll do that so that you can't do that, but I can do that so you can see it better. All right, and so if you need a moment to write that down, you just pause the tape, and actually maybe I'll write it on the next, I'll write it on the next page too. So if you needed a moment, it's okay, it's going to be over here too. All right, so we're going to put division, multiplication. It's going to be division if a is an integer. I think I wrote it nicer too. And it's going to be multiplication. That's going to be by the reciprocal if a is a fraction. All right, so in this case, it's not a fraction, it's an integer. So we're going to divide both sides by 5. All right, so now 5s will cancel, right? So So now we have 2/5 equals x plus 4 squared. Now we need to take a square root. In this case, we're going to need to split this into two radicals because I could not simplify, and they both be, and the whole thing is just plus or minus, because I could not simplify 2/5, right? That's not a fraction that reduces at all. And don't change to a decimal. And then over here we have the square root of x plus 4 squared. All right, so here I actually can't do anything with either of those radicals other than I don't want a radical in the denominator. So this happens to be one that I'm going to have to rationalize. So this one's a little bit different. So I'm just going to write here, rationalize if there is a radical in the denominator. This really won't happen very often to you. Probably not at all, but it's still good to know what to do. All right, so we have plus or minus the square root of 2 divided by square root of 5. And the only way I can get rid of that square root of 5 that's in the denominator is to multiply it by the same value. Now over here, the square and the square root canceled. All right, so now square root of 2 times the square root of 5 is the square root of 10. You can multiply radical by radical so long as they're both the same index, the same root. These are both square roots, so you can do that. The square root of 5 times the square root of 5, that's going to be the square root of 25. That's a perfect square. I'm going to continue over here because I'm almost done. All right, so square root of 25, that's 5. So now I've got plus or minus the square root of 10 divided by 5 equals x plus 4. And now all I have to do is subtract 4 from both sides. So x is going to be equal to negative 4 plus or minus the square root of 10. I didn't extend the page. I didn't need to. I didn't want it to just start moving. All right, so that's going to be negative 4 plus or minus the square root of 10 divided by 5. If you had any trouble understanding the steps for rationalizing, I can go over those with you. But that's the end of this problem. So now this one does have two x-intercepts. All right, so they are negative 4 plus the square root of 10 divided by 5, 0, and negative 4 minus the square root of 10 divided by 5, 0. So yes, those are x-intercepts, but to graph them, you'd have to get a decimal equivalent to graph those because it's not like you can find that point easily on the graph without having a decimal to work with. So when we're solving, give me the exact solution. And then afterwards, if we're graphing, then you can change that to a decimal for your graph so you can graph it. Right? But that's all there is to this one. This one was just a little bit more involved. You won't find that you're going, on the graphing ones at least, that you're going to have a lot of radicals, or probably you're not going to have any radicals to rationalize. But it might come, you might see it on a solving, so this way you knew what the steps were. All right, we have one more, and I saved the easiest for last. So we want to find the x-intercepts. Again, we're going to substitute 0 for f of x equals 2 times x plus 3 times x plus 1. We're going to divide both sides by 2, right, to get rid of that divided by 2 because we want to solve for the x. So 0 equals x plus 3 and x plus 1. So now all I have to do is set my factors equal to 0. It's already factored for us. So remember, each of our different formats has a pro and a con. Or I should say a pro. And the pro is that something, the x-intercepts, the y-intercept, or the vertex, is easier to solve than the other formats. So for standard form, it's the y-intercept. For vertex form, it's the vertex. And for intercept form, it's the x-intercepts. Because sometimes the x-intercepts can be the most amount of work, I like equations in intercept form because you have the least amount of work. Right? It's not that hard to plug in 0 to find the y-intercept, and it's not that hard to average your x-intercepts and divide by 2, right? Plug something in. That's easy, right? Sometimes solving is the harder part, but on this one, the solving is so easy. So -3, 0, and -1, 0. Look at that, again. Well, that's twice. Actually, that's 3 times. 3 times we've seen the same x-intercepts. There. Not this one, because this one didn't have anything to do with the other problems. Right here. And right here. I wonder why. Well, in the next podcast, let's find out why we had the same x-intercepts. All right, so I'll see you in the next podcast. Bye for now.